Another hard day beating the bad guys. I love my job as a superhero. How about you, Foxface?
Yes, me too. Remember we said we would discuss our recruitment of the Year 12 students into the Fantastic Physicists program on this journey. So stop daydreaming, there are a few of them in particular I want to talk to you about.
Oh really? Who?
Miss Nolan mentioned that Nicola Arnold had completed many of the tasks ahead of time. She could be a great leader if she is retaining all of that knowledge. On the other hand, she has not had any work handed in from Max Spray. Yet, we will keep an eye on him, I think.
Yes, let's fire some questions at the group. Michael Preety in the front row, what does it mean for an object to be in thermal equilibrium with its surroundings? Michael?
Right, well done Michael. Just to confirm, as the line is a little fuzzy. You said that thermal equilibrium is when there is no overall flow of heat between two areas because there is no temperature difference.
Right, and heat will always flow from hot to cold, but James, when do we have a maximum rate of flow of heat between two objects? James?
Very good. If the difference in temperature is high, then rate of heat flow is high. So it's clear the group have learned a lot already about thermal physics, but today's lesson will really challenge them. Our title is Specific Heat Capacity. Birdhouse Head, can you explain why this is relevant to our superhero work?
As a superhero, we are regularly called to burning buildings and must analyze very quickly how to safely enter the building without danger to ourselves or others.
We must understand that heat travels at different rates through different objects in order to safely handle them. This is measured as heat capacity of a material.
Heat capacity. Heat capacity is a measure of how much heat energy is required to raise the temperature of an object by 1 degree. And it depends on two things: mass and the material itself. Each material has a value for heat capacity, which is specifically for the amount of heat energy required to raise the temperature by 1 degree, for 1 kilogram of that object.
That's why they're called the specific heat capacity. So it's easy really. Specific heat capacity is the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 degree. You know what, Birdhouse Head? Even though they are only learning, we must give them the mission early. We only have 45 minutes left before it's too late for the latest victims of the evil criminal Science Sucks.
You're right. Listen, all of you, Pierce in particular, no daydreaming. I want you to take this seriously. There's a deadly fire raging in Debden. One of the warehouses is on fire and there is a family of 4 stuck inside with only 45 minutes of oxygen left.
The firefighters are desperately trying to gain access to the building. There are 4 doors, made of steel, copper, brass and aluminum, all too hot to touch. They are cooling the doors with water.
Here are your questions. 1. Which door will cool down first? 2. Why is water a good coolant? Good luck. We need answers in 45 minutes at the latest.
Remember, use your expert powers of physics for good and not evil.
As always,